What we have up on screen at the moment.
In this lesson, the teacher is using data from a 2011 census to introduce the idea of hypothesis testing. It's an idea that students can often find difficult. The data concerns how people travelled to work back in 2011. They began by analysing this available data.
So what we're going to do is, we're going to write a formula to find the percentage that travelled by train. Now this session was really interesting. I started off looking at something like an Excel spreadsheet of loads and loads of boroughs, the data that was relevant to them. We calculated the percentage of people that were travelling to work by train, and then we ranked them, and we saw that all the London data was right at the top. Do you think people's habits have changed?
Having ranked the data, the students begin to suggest possible ideas for how travel might have changed over time.
Yeah, definitely.
And you think less, Faisal?
No, I think more.
Because people can travel by cars.
We talked about how train travel is getting so much busier, trains are becoming unreliable, lots of strikes and stuff like that happening. We asked them if they thought more people travelling to work by train or less. Let's take Bromley for example. If we were going to take some data...
The teacher now introduces the idea of hypothesis testing by focusing on the data for people from Bromley and how to test if people's behaviour has changed or not. The students need to consider how many, in that survey of 200 people, would need to be travelling by train to provide convincing evidence of change. That is, that the percentage has changed from 30% since the 2011 census.
What would be a significant change for us to go, right, yeah, I actually think the percentage has gone up or the percentage has gone down? Let's take a look at some data here just now.
To help, the teacher introduces some modelling.
Now what I have here is we're going to have 200 random numbers.
The random numbers form a model simulating the situation as if there were no change compared with the 2011 census, i.e. still 30%. The model has been created using a random number generator, generating 200 numbers between 1 and 10. The numbers 1, 2 and 3 are shown in red, and the number in blue shows how many of the sample of 200 are the numbers 1, 2 and 3.
So at the moment we've got 61 out of 200 that are 1, 2 or 3.
Yeah.
Is that what we would expect? So
Yeah,
61 out of 200. So you get different numbers coming up. Sometimes it was 60, 61, 62. And sometimes you get one that was quite high, like you might get 75 one time or something like that. And we were just sort of asking that question, well really, how high or how low would this need to be for you to be like, hold on a minute, this doesn't seem right. This seems like something's happened, something's changed. There's significant evidence there. So it was really sort of like building in that idea. What sort of a probability distribution have we got here?
Next, the teacher helps the students connect these ideas with what they may already understand about the binomial distribution.
What things are we looking for when we're looking for something that's binomially distributed?
Fixed trials and
Fixed number of trials,
fixed probabilities.
fixed probabilities. Right, first thing, do we have a set number of trials?
Yes.
Yeah, how many trials have we got?
200.
For an individual one of these, what's the probability?
3 out of 10.
Does that probability change?
No.
No. Let's take a look at what this actual distribution looks like. What's our mean? 60.
Yep.
If I wanted to be 99% positive, if we see a number that's outside of this range, we've got to say that looks really out of the ordinary. This data isn't coming from something with a probability of 0.3. What if we make it 55 and 65?
Using a common dynamic graphing package, the teacher and students find the probabilities of different sets of results for the situation where there is no change in the percentage travelling by train.
40, okay, so 40 and 80. There we've got a 99% chance that our number's going to fall between 40 and 80. So it would have to be really out of the ordinary for it to be something bigger than 80 or smaller than 40, wouldn't it? It was difficult because it brought in a lot of different things in one go. Thinking about the binomial distribution, thinking about how the distribution looks on a graph, and thinking about the ideas of those sort of like critical values. It was hard. It was also something the students found quite hard because it was the first time they'd seen anything to do with hypothesis testing.
Okay, do you think they understood that?
I think what they came out with was a lot of questions. It was a good way of getting them thinking and a good way of sort of like introducing the idea.